Assalamualaikum and good day to doctor and friends. My name is Ernina binti Abu Bakar. Today, I would like to present about zooxanthellae density of stress coral. Zooxanthellae is unicellular, dinoflagellates and a single-cell algae, which is golden brown algae. Zooxanthellae have mutualistic interaction with corals, which is both of them will get benefits. Zooxanthellae will help corals get enough energy to build reef, provide oxygen and also remove some of the coral's waste. In return, coral will protect by giving shelter to the algae and both of them will share some nutrients together. Zooxanthellae also do photosynthesis, which is turning the light and carbon dioxide into foods. The coral colors also get from zooxanthellae and other and zooxanthellae also can be found in jellyfish, giant clams and nudibranchs. For research background, the corals become stressed when the changes in the environment occur, and to avoid from further tissue damage, the corals will expel the zooxanthellae and thus corals become bleachings. The factors that can cause coral stress is changes of water temperature, either the temperature become high or low, the presence of xenobiotic, which is chemical substances that are foreign to the coral, and the corals overexposed to the sunlight, the dilution of seawater, and lastly, the high amount of inorganic nutrients. Justification for this research are since zooxanthellae do photosynthesis, the oxygen will be produced. More numbers of zooxanthellae, more oxygen will be released to the world. Next, corals cannot get foods and color without the presence of zooxanthellae. So, zooxanthellae is really important to the corals. Coral reef also protect the coastline from the erosion and storms. And next, coral reefs are safe shelter to most of all marine animals. So, without coral reef, marine animals and also we humans will be affected. The objective of this research are to calculate the density of zooxanthellae in stressed corals and to compare the zooxanthellae density in stress with healthy corals. For the sample site, we decide to do sampling in two different sites, which is the first site is near to the Bidong Bay campsite, while the second site is a bit far from the campsite and shore. This is because the corals that live near the campsite with the presence of humans activities probably more stressed than corals that live far. Net for methodology, first, collect two replicate branches of the coral. Secondly, all coral branches will be frozen in liquid nitrogen and maintained at negative 30 degrees Celsius. And then, to identify the density of zooxanthellae, decalcification technique will be chosen and the branches will be removed from the freezer and fixed in 10% of buffered formalin for 4 days. Next, each sample then will be placed in an individual container with 5% hydrochloric solution to gently decalcify the sample over all 5 days. And then each container will be refreshed with new hydrochloric solution on days 3 and 4, and when the skeleton was dissolved, the remaining tissue samples will be triple rinsed and stored in 70% ethanol. And then, lastly, sample will be mixed with an ultra-turret T25 basic homogenizer for 2 minutes 0.0025 milliliter. A record of this homogenate will immediately place on to Neubauer Imperative Text Profounder. This is the Gantt chart. For the expected result, the Zooxanthellae density of stressed corals were less than healthy corals. Next, the density of Zooxanthellae that lost are not too high, and there are not a lot of corals that stress and bleach in Rideau Island. And lastly, there will be few ways to prevent and treat the corals from death. This is the references that I use, and that's all from me. Thank you.